Good morning, students. In our previous class, what we have discussed is the electric field intensity due to line charge on a uniformly charged line charge plane. We have derived the mathematical equation for unit vector in terms of coordinates, and we have seen the limiting condition, right, when the charge is at infinite length. So we have seen the mathematical model for all such cases. But now in this particular session, we are considering electric field at a point on the axis of a charged circular ring. So this is the case we need to analyze in this particular session. We need to derive the mathematical model for this particular case. So in order to do so, let us consider a circular ring which is charged positively. Let us consider a circular ring which is charged positively of radius r. The radius of this circular ring is r. So let us consider the elementary length dl at point A on the circumference of this circular ring. Consider the elementary length dl at point A on the circumference of this circular ring, charged circular ring. Let P be the point at which electric field intensity to be determined, which is along the axis of this circular ring. Okay, so this is along the x-axis direction. Join A and P. The distance between point A and P is considered to be r. The distance between origin O and point P is considered to be x. Distance between A and O is considered as r. Okay, this is the vector r which is having the unit vector a cap r. So the vector acts along the line. This is vector E. So if we resolve this vector into x-axis and y component, a rectangular component, this is Ex and this is Ey. Got it? These are the resultants of this vector E. Ex along the x-axis, Ey along the y-axis. Now it forms the angle theta, which forms the angle theta. So this is the geometrical consideration we need to have. So the line charge density rho L is given by dq divided by dl, because according to the definition of line charge density, charge per unit length, we are considering the elementary charge at this particular elementary length dl, hence line charge density at this point is rho L is equal to dq by dl. Now electric field intensity at point P due to the elementary charge dq is given by the Coulomb's law equation, that is dE is equal to dq divided by 4 pi epsilon naught into r square into a cap r. This is the equation we have derived this equation, right? So this is the elementary electric field intensity due to elementary charge dq. But in order to obtain the total electric field intensity at point P, we need to have all the elementary distances along this circumference of this circle we need to consider. So in order to do so, we need to integrate all the elementary components, right? So for that case, we need to have the equation for this first. We know that dq is equal to rho L into dl, right? According to this equation, if we cross multiply this, dq is equal to rho L into dl. Then what about a cap r and r square component, where a cap r is the element unit vector and r square is the distance between point A and P. This is the equation for dE. Now we know that total electric field intensity E is equivalent to the sum of the resultants Ex and Ey. But here Ey is considered to be 0, because see, if we consider the exact diametrically opposite point here, diametrically opposite point to this dl here, the EY component acts upwards. So these two components cancel each other because of opposite direction with same magnitude. Hence, the summation of all EY components will be resultant in 0. But what about EX component? EX component gets add up for the entire circumference of this circle, for the points along the entire circumference of this circle. Hence, EY component is considered to be or assumed to be 0 in this pursuit of continuing this derivation. Okay, so keep that in your mind. Only EX component will be retained, EY component becomes 0 because these two gets cancelled because of opposite direction, act of opposite direction. Got it? Continuing with this, see, as I said earlier, DEY component is assumed to be 0 and DEX is equivalent to DE cos theta, where cos theta is equal to x by r according to the right angle triangle AOP. See, according to this triangle AOP, cos theta is equal to adjacent by hypotenuse, that is x divided by r. That's what I have written here. Then substitute equation 1, see, consider this as equation 1 into this equation. Therefore, DEX is equal to, DE means DQ divided by 4 pi epsilon naught r square into a cap r into cos theta, right? See, DEX is equal to, what is DQ? DQ is equal to rho L into DL, rho L into DL divided by 4 pi epsilon naught r square into cos theta into a cap r, right? What is cos theta? Cos theta is equal to x by r. Substitute that also. DEX is equal to rho L into DL divided by 4 pi epsilon naught into r square into x divided by r into a cap x, right? Then equation becomes DEX is equal to rho L into DL divided by 4 pi epsilon naught r cube into x into a cap r, right? A cap r. This is the equation. Then what is r? What is r? R can be represented in this fashion, right? If we consider the same right angle triangle AOP, if we consider same right angle triangle AOP, this is theta and this is 90 degree, then this distance is r, this is capital R and this is x. According to Pythagoras theorem, hypotenuse square is equal to r square plus x square. What I need here? R. So the equation for r is equal to square root of r square plus x square. In other words, r is equal to r square plus x square whole power 1 by 2. Got it? Then substitute this r into this equation. Then it results in DEX is equal to rho L into DL into x divided by 4 pi epsilon naught into r cube means r square plus x square whole cube power 1 by 2 means whole power 3 by 2 into a cap r. This is the equation for DEX. Okay. There we know that DEY is equal to 0. Then DE is equal to DEX component plus DEY component. We know that DEY component is 0. Therefore, in order to get total electric field intensity E, we need to integrate all the dE components, right? So in other words, we can say integration of dEx components, right? Now continuing with this, total electric field intensity E is equal to integration from 0 to 2 pi r according to the circumference of this circle, perimeter of this circle, 2 pi r, 0 to 2 pi r into of dEx, right? So E becomes, total electric field intensity E becomes, see, substitute dEx here. What is dEx? Rho L is constant, x is constant, take it outside, 4 pi epsilon naught into r square plus x square whole power 3 by 2 is constant. We have taken it outside. Integration from 0 to 2 pi r into what? dl, right? So this is what we have got. So we need to integrate this with respect to 2 pi r. So if we continuing with this, so let me continue here. See, total electric field intensity E is equal to rho L into x divided by 4 pi epsilon naught r square plus x square whole power 3 by 2 into 2 pi r, because this is L. So if we apply limits 2 pi r minus 0, then we will get 2 pi r only. Then equation becomes E is equal to rho L into 2 pi r into x into a cap r. This remains constant, divided by 4 pi epsilon naught into r square plus x square whole power 3 by 2 into a cap r. We know that Q is equal to 2 pi r into rho L. So Q is equal to 2 pi r into rho L. Therefore, E is equal to Q into x divided by 4 pi epsilon naught into r square plus x square whole power 3 by 2 into a cap r. This is the total electric field intensity at a point P due to the elementary part on the charged circular ring. Okay, we need to consider the special case here. What is that special case? The limiting condition for this particular derivation is what happens to the total electric field intensity at point P when this point is shifted at the origin of this circle. So then if this point P is shifted to this origin, then x becomes 0, right? So the limiting condition is limiting condition 1. What is that? When P is at origin. When P is at origin O, then x is equal to 0. When x becomes 0, obviously total electric field intensity becomes 0. Substitute x is equal to 0. 0 into anything? 0. Therefore, total electric field intensity at point P due to the charge is circular ring is 0. This is the limiting condition 1. So limiting condition 2. What it says, when this point P is kept at very large distance, Therefore, x is very much larger than r. That is, what is the meaning? When point P is kept at very large distance from the origin means the radius of this particular circular ring is negligible when compared to the distance between origin and the point at which the field to be determined, right? Therefore, that condition is represented as x is very much larger than r. This is the case. When the distance between origin and point P is very much larger than the radius of this circular ring, then this happens. What will happen? Therefore, see, when this condition occurs, we need to neglect r square component here, right? In this equation, if we neglect r square component, because x square is very much larger than r square, we can neglect this, right? So total electric field intensity E becomes, see, Q divided by Q into X divided by 4 pi epsilon naught, neglect r square component, we left with x square whole power 3 by 2. 2 gets cancelled, x cube, okay, into x cube into a cap r, right? This is what we are going to get. So continuing with that, see, total electric field intensity E is equal to Q divided by 4 pi epsilon naught into x square into a cap r, because x and x cube, so we left with x square. But what this equation is not yet completed, because we know that according to Pythagoras theorem, r square is equal to capital R square plus x square we have considered. According to this limiting condition, when r square component is neglected, then small r square is equal to small x square. These two distances are equivalent. Under that case, total electric field intensity E is equal to Q divided by 4 pi epsilon naught into r square into a cap r. Now look at this equation and tell me how it resembles. So this equation resembles the total electric field intensity at a point due to a point charge, which is equivalent to field due to a point charge, right? And under this limiting condition, this equivalent total electric field intensity is equivalent to the point charge equation. Got it? Understood? Okay. Continuing with the next topic, electric field due to sheet of a charge, that is surface charge. Electric field due to surface charge. Now what is the assumption we need to take is, consider the infinite surface charge. Consider the infinite area surface charge along xz plane. So we have considered this infinite sheet charge along xz plane. See, the assumption is this infinite sheet charge is made up of the longitudinal or line charge of infinite numbers, each of distance dx. That is, this sheet charge is made up of infinite number of line charges, each of distance dx. Therefore, the elementary line charge of length dx is considered in this particular case. So these kind of infinite number of line charges are there in order to obtain this complete surface charge, right? So this is kept along the xz plane. Okay, let O is the point on the surface charge and P is the point at which electric field intensity to be determined. So the distance between OP is considered as R. Then let us draw a perpendicular line to the surface, that is OQ. OQ is the perpendicular to the surface of this charge, and join Q and P, which is having a distance r, okay, join Q and P, which is having a distance r, and forms the angle theta between the perpendicular line to the surface and the point P. Since these two lines are parallel, the angle between DEX component and DE component is also equivalent to theta. Okay, but here the special condition is dy component gets cancelled. Why dx component get cancelled? In the previous case, which component gets cancelled? Dy component gets cancelled, but here dx component gets cancelled. Why? Because so dx component acts along this point. If we consider another point, see, let us consider Q as the origin of this line charge. So dx is acting along this line. If I consider another one in the opposite direction, so we will get the equal magnitude with opposite direction, and dx component gets cancelled like this. See here, if I take like this, dex is in negative direction. This gets cancelled. These two gets cancelled for the entire line charges along this xz plane. Hence, dex components are 0 in this particular case. Only we left with dy component. Therefore, the total electric field intensity at point P is contributed by only dy components. Only dy components. Got it? So, dEy components is equivalent to dE into sin theta. What is dE? dE is equal to rho L divided by 2 pi epsilon naught into r into a cap r. Where this equation comes, we have already derived this equation for line charge. Electric field intensity due to line charge. Already the equation have been derived for this. So we are taking directly from the previous derivation. dE is equal to rho L divided by 2 pi epsilon naught r into a cap r. Then substitute this equation into dEy component. Therefore, dEy component is equal to rho L divided by 2 pi epsilon naught into r into a cap r into sin theta. Right? What is rho L? Rho L is equal to rho S into dx. dEy is equal to rho S into dx divided by 2 pi epsilon naught into r into a cap r into sin theta. Right? So what is r? R is equal to r cot theta. Sorry, x is equal to r cot theta. R is equal to r cosecant theta. Therefore, dEy is equal to rho S into dx. What is dx? dx is equal to minus r cosecant square theta, because x is equal to r cot theta. Differentiation of cot theta is cosecant square theta, minus cosecant square theta. I have written like this. This can be written as minus r into cosecant square theta into d theta into a cap r into sin theta whole divided by 2 pi epsilon naught into r. What is r? R is equal to r cosecant theta. R cosecant theta and square gets cancelled. This r gets cancelled. We left with dEy is equal to minus rho S into cosecant theta into d theta sin theta a cap r divided by 2 pi epsilon naught. Right? What is cosecant theta? Cosecant theta is 1 by sin theta. Therefore, these two gets cancelled. Right? Then the equation gets reduced to dEy is equal to minus rho S into d theta into a cap r divided by 2 pi epsilon naught. This is the equation for the component, a resultant component along the y-axis. Now, the total electric field intensity E is equal to integration of all the elementary electric field intensities, but in this case we have only the y components, x components are 0, therefore dEy is only considered. Therefore E is equal to integration from minus infinity to plus infinity dEy component. Why the integration limits is considered to be minus infinity to plus infinity? Because we have considered the surface charge of infinite area, infinite length. We need to integrate from minus infinity to plus infinity. So that's what we have taken. But here we cannot integrate from minus infinity to plus infinity because we need to change these limits to in terms of x, right? See, if x is at minus infinity, if this x is at minus infinity, what happens to theta? Theta becomes 180 degrees here. When this x is at minus infinity, then theta becomes 180 degree. When this x is at plus infinity, then theta becomes 0, right? So we need to consider that when x is at minus infinity, theta becomes 180, that means pi. When x is at plus infinity, then theta becomes 0. We need to consider that. When x is equal to minus infinity, what happens to theta? Theta is equal to pi. When x is equal to plus infinity, what happens to theta? Theta is equal to 0. Then the summation limit becomes integration from where to where? Minus infinity means pi. Pi to 0 dEy component. We need to integrate with these limits pi to 0, not 0 to pi. So integration is from pi to 0. Okay. See, therefore the total electric field intensity E is equal to integration from pi to 0. What is dEy? dEy is equal to minus rho s into d theta divided by 2 pi epsilon naught, right? So E is equal to, take minus outside, 2 pi epsilon naught integration from pi to 0 into d theta. See, if I replace this negative sign by plus, then summation limit changes. Then this becomes 0 to pi, right? If I replace this negative sign with the positive sign, the integration limits changes. So that's what I have substituted here. Therefore E becomes rho s divided by 2 pi epsilon naught into what? Pi minus 0, upper limit minus lower limit. So E is equal to rho s, pi gets cancelled, divided by 2 epsilon naught into a cap r. This is the total electric field intensity due to sheet of a charge, that is surface charge, right? This is the equation. Got it? Okay. Okay. Let us solve some numerical problems based on the topics which we have learned till now. So till now what we have learned, so we have seen the Coulomb's law, so vector algebra, and the electric field intensity due to various cases, line charge, volume charge and surface charge densities. So let us see numerical problems on those topics. See, consider the first numerical problem. So let me read the statement. A point charge Q1 is equal to 300 microcoulomb located at this location 1 minus 3 meter experiences a force F1 which is given by 8 a cap x minus 8 a cap y plus 4 a cap z Newton due to a point charge Q2 located at 3, minus 3 and minus 2 meter. Determine Q2. So by looking at this problem statement, what they have given is there are 2 point charges Q1 and Q2. So due to the point charge Q2, Q1 experiences a force F1 that is given by this equation. These 2 point charges are located at these coordinates. Then we need to calculate the unknown point charge Q2. That is the problem statement given, right? Let me write the given here. So there are 2 point charges Q1 and Q2. Q2 here, Q1, which are separated at a distance R. So Q1 experiences a force F due to the point charge Q2. Therefore, the direction of this vector is towards Q1, where A cap R is the unit vector. Q1 is located at 1, -1 and -3 meter. Q2 is located at 3, -3 and -2 meter. The force is given by 8 A cap x minus 8 A cap y plus 4 A cap z. We need to calculate Q2. Q2 is unknown. Q1 is given by 300 microcoulomb charge, right? So which equation we need to incorporate here? Since we have 2 point charges and force equation, we need to use Coulomb's law equation, that is F is equal to Q1 into Q2 divided by 4 pi epsilon naught into R square into A cap R, right? So since the F1 is the force experienced by Q1, then this F becomes F1. Got it? So we have Q1, but we don't know the value of Q2. We need to evaluate this Q2 from this equation. So before going to evaluate Q2, we have one more unknown component, that is unit vector A cap R. We need to calculate the A cap R unit vector. A cap R is given by R divided by magnitude of R. What is R? The distance between these 2 point charges, which can be evaluated by using distance formula. How to calculate the distance between these two? By using the given coordinates, that is by using tip minus tail methodology, that is 1 minus 3 into A cap x plus -1 minus 3 into A cap y minus 1 minus of -3 into A cap y plus -3 minus -2 -3 minus of -2 into A cap z. This is the distance between those 2 points, that is -2 A cap x plus 1 minus of minus means plus -1 plus 3 means 2 A cap y plus 2 A cap y. Here -3 plus 2 means -1 A cap z. This is the distance between those 2 points. Now we need to calculate the magnitude of R. The magnitude of R is equal to square root of -2 square plus 2 square plus -1 square. The magnitude part we need to consider. Therefore, magnitude of R is equal to square root of how much? 4 plus 4 plus 1, 9. Therefore, magnitude of R is equal to 3. We need to consider this. Magnitude of R is 3. Then substitute all these components into this equation. Therefore, F1 is equal to, what is this? Q1. Q1 is 300 into 10 power minus 6 coulomb into Q2 divided by 4 pi epsilon naught into R square. R square is considered as magnitude of R square. Just for simplifying this equation in a simpler manner, so we are considering the magnitude. If I consider the vector, so it can take more time to solve. Hence, I am considering this magnitude of R into A cap R. What is A cap R? So, A cap R can be substituted further. 3 and also we know that 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught can be approximated into 9 into 10 power 9 farad per meter. Okay, 1 by 4 pi epsilon naught can be replaced by 9 into 10 power 9. So therefore F1 is equal to 9 into 10 power 9 into 300 into 10 power minus 6 whole divided by r square. What is r? 3. This becomes 3 square into Q2 into what is a cap r? A cap r is equal to r divided by magnitude, that is minus 2 a cap x plus 2 a cap y minus a cap z divided by 3. This is a cap r, unit vector. This is the equation for unit vector. Now solve this. 3 square and 9 gets cancelled. 3 and 100. Okay, then f becomes, see, 10 power 9 into 100 can be written as 10 power 2 into 10 power minus 6 Q2 into minus 2 a cap x plus 2 a cap y minus a cap z. What is the resultant of this? 10 power 11 into 10 power minus 6. What are you going to get? 10 power 5. 10 power plus 5 into Q2 into minus 2 a cap x plus 2 a cap y minus a cap z. We know that F1 is given, right? F1 is given as 8 a cap x minus 8 a cap y plus 4 a cap z. Substitute here. 8 a cap x, okay, minus 8 a cap y plus 4 a cap z is equal to 10 power 5 Q2 into minus 2 a cap x plus 2 a cap y minus a cap z. Take 4 common out of this equation. Therefore 4 into 2 a cap x, take minus 4 as common. If I take minus 4 as common, then this becomes minus 2 a cap x plus 2 a cap y minus a cap z is equal to 10 power 5 Q2 into minus 2 a cap x plus 2 a cap y minus a cap z. See, these two terms are identical, therefore these two gets cancelled. Then we left with minus 4 is equal to 10 power 5 into Q2. What we need to calculate? Q2. Q2 is equal to minus 4 divided by 10 power 5. Then Q2 is equal to, if I neglect the negative sign, then this becomes 40 microcoulomb. Q2 is 40 microcoulomb, because if 10 power 5 goes to numerator, then this becomes 10 power minus 5. This can be represented as 40 microcoulomb. This is what they are asking you to determine. Determine Q2. Q2 is given by 40 microcoulomb. Understood? Thank you. Let us solve one more problem. So let me read this. 2 point charges Q1 is equal to 50 microcoulomb and Q2 is equal to 10 microcoulomb located at the coordinates minus 1, 1, minus 3 meter and 3, 1, 0 meter respectively. Find the force on Q1. Again, in this problem statement also, we need to find the force which is exerted by charge Q2 on Q1. They are asking. But in the previous case, the force has been given, Q2 was unknown. But here Q2 has given, F is unknown. But the condition of operation remains same. That is, the Q2 is exerting force on Q1. The direction of the vector remains same in this particular problem also. Let me describe the problem statement here. There are 2 point charges Q1 and Q2 located at minus 1, 1, minus 3 and 3, 1, 0 respectively, which are separated by a distance r. Q2 is exerting force on Q1, hence the direction of vector is towards Q1. A cap r is the unit vector. The force is unknown here, F to be calculated. In the previous case, Q2 was unknown. So Q2 is given by 10 microcoulomb. Here Q1 is given by 50 microcoulomb, right? So let me solve this. So we know that the Coulomb's law is given by F is equal to Q1 into Q2 divided by 4 pi epsilon naught into r square into a cap r, right? So we don't know the unit vector a cap r. A cap r is given by r divided by magnitude of r. So what is r? R is equal to, take the distance formula, minus 1 minus 3 minus 1 minus 3 into a cap x plus 1 minus 1 into a cap y plus minus 3 minus 0 minus 3 minus 0 a cap z. This component becomes 0. 1 minus 1, 0. Therefore, r is equal to minus 1 minus 3 means minus 4 a cap x minus 3 a cap z, right? This is the distance between those 2 points. Magnitude of r is equal to square root of minus 4 square plus minus 3 square, which is given by how much? 16 plus 9, square root of 25, which is equal to 5. Magnitude of r is 5. Therefore the unit vector a cap r is equal to how much? Minus 4 a cap x minus 3 a cap z divided by magnitude of r, that is r. This is the unit vector we have got. Now substitute all these components into the Coulomb's law equation. What is Q1? 50 into 10 power minus 6 into, what is Q2? 10 into 10 power minus 6 whole divided by 4 pi epsilon naught. 1 by 4 pi epsilon naught can also be written as 9 into 10 power 9. We know the approximation from the previous problem. 1 by 4 pi epsilon naught can be written as 9 into 10 power 9. What is r square? 5 square. R square can be written as 5 square into the unit vector. What is unit vector? Minus 4 a cap x minus 3 a cap z divided by 5. This is the unit vector. Now solve this. See how much we are going to get? F is equal to 50 into 10. How much? 500 into 10 power minus 6 into 10 power minus 6 into 9 into 10 power 9 divided by into minus 4 a cap x minus 3 a cap z divided by 5 square into 5 here. See, 5 ones are 500. Okay, means F is equal to how much we are going to get? Okay, 10 power minus 12 into 10 power 9 into 100 can be written as 10 square into 9 divided by 25, okay, into minus 4 a cap x minus 3 a cap z. See how much we are going to get? 10 power 11, 10 power plus 11 into 10 power minus 1 minus 12. So the resultant is 10 power minus 1 into 9 divided by 25 into minus 4 a cap x minus 3 a cap z, right? So this can be coming towards f is equal to 9 divided by 250 into minus 4 a cap x minus 3 a cap z. So this is Newton. Force is expressed in terms of Newton. 9 by 15 into minus 4 a cap x minus 3 a cap z Newton. So if you try to solve further, you will get the answer in decimal points. Got it? So you can solve this equation further by calculating magnitude of f and angle of f.